Hero of the year is acetylcholine, discovered in 1913. Some basic physical characteristics: it has a molecular weight of 146.21 grams per mole, a melting point of 148 degrees Celsius, a boiling point of 265.84 degrees Celsius. Solubility in water is about 0.14 grams per liter, and its molecular formula is C7H16NO2+. And we have two 3D renderings of it and one bond line diagram. Some basic chemical characteristics. The stability in air and the flammability have not been established or determined. As far as toxicity goes, there's acute effects in intraperitoneal LD50 of 250 milligrams per kilogram in rats had behavioral effects such as convulsions or effects on the seizure threshold. Its molecular shape has no symmetry. It has a tetrahedral N plus C3H9 end with an acetyl group on the opposite end. In between is a branched carbon chain, so it's made by joining acetyl from acetyl-CoA and choline. And it has no chiral center, therefore no enantiomers, nor stereoisomers. Why is it famous, you ask? Well, acetylcholine was the first neurotransmitter to ever be identified, and it is an important neurotransmitter for movement, memory, and cognition, but it does have numerous functions in the body. Is there anything that mimics it? Yes, there is. Nicotine binds to the same family of neuroreceptors and activates them the same way that acetylcholine does. And there's other drugs that mimic acetylcholine, like muscarine, Chantix, Alzheimer's drugs, tensilin. And muscarine, a natural alkaloid found in mushrooms, acts on cholinergic neurons in a similar way that acetylcholine acts on them. What molecular class does it belong to? It belongs to the class of acetylcholates. They are acylated derivatives of choline. So what choline is, it's a nutrient used in cell growth and metabolism, and it comes from our diet like eggs and beef liver and nuts. And acyl is a chemical group characterized by a carbon double bonded to an oxygen and an R group. And so we have a little equation. Acyl plus choline makes acetylcholine. How was it discovered? This is a story, all right. So naturally occurring acetylcholine was accidentally discovered by Henry Dale and his colleague Arthur Irwins in 1913 when they were studying the pharmacology of ergot of rye. However, by 1914, they didn't know that there was a physiological effect, and due to the war efforts, research on acetylcholine came to a halt. But in 1921, Austrian pharmacologist Otto Loewi discovered a chemical which he called Werkstoff that slowed the beating of frogs' hearts. And Dale once again became interested in this chemical because of Otto Loewi's research, and he also again accidentally discovered acetylcholine in mammalian bodies. And during the 1930s, there were many experiments held to determine acetylcholine's function and to understand chemical transmission of nerve impulses in general. And finally, in 1936, Dale shared the Nobel Prize in Physiology or Medicine with Otto Loewi for their discoveries relating to the chemical transmission of nerve impulses, and it is found in the peripheral and central nervous system in a group of neurotransmitters called cholinergic neurons found in parts of the brain and brain stem, and it's in the somatic nervous system, playing an excitatory role that activates muscle contractions. It does come from multiple places. It is synthesized in the cytoplasm of the nerve terminal and present in non-neural cells, and it exists in plants, animals, and fungi. Does it exist in large amounts, or is it rare? It definitely exists in large amounts. It's necessary for many bodily functions such as movement and memory, and it's the most abundant chemical messenger. So it's found throughout the body. And drugs and chemicals that inhibit the function of acetylcholine may lead to many negative effects on muscles or even death, and a deterioration of cholinergic pathways in the central nervous system is accredited to contributing to Alzheimer's disease. Oh no. It is my molecular hero of the year because acetylcholine contributes to every movement, from contractions of the heart to the blinking of our eyes. Without acetylcholine, we would not have the ability to move, remember information, learn, and much more. It can play an excitatory role or an inhibitory role, giving this molecule a diverse range of functions, and it inspired many experiments relating to neurotransmitters and chemical signals, helping the scientific community explode with theories about chemical transmission in the nervous system. And here are some sources, and here are my credits. Thank you so much.